Good morning. Can you hear me?
Yeah.
Okay, cool.
Yes.
Okay, cool. Good, good, good. Well, welcome. We'll give it a few minutes for people to join in. And then we'll go ahead and begin. I updated my computer finally, so hopefully this call won't get dropped, but I see you guys all on the computer, so great. Wow. All right, we'll give it a few minutes while people log in, and while they're doing that, can you guys make sure you have out your Math 8 notebook and a straight edge just in case, like your ID card or a ruler or a protractor or something that you can draw lines with. Okay, and we'll give it a few more minutes for everyone to get logged in. Okay. Okay, let's see. Do you guys hear the baby?
Yeah.
Huh?
Yeah.
Yes.
Yes? Okay. Is she too loud?
No.
Okay. Okay, cool. All right. Give it a few more minutes, okay? See if people join in, and then if not, we'll go ahead and begin. I'm just trying to change some of my settings real quick. Okay, cool. Okay, let me try sharing my screen while we'll wait. Okay, share screen. Okay, guys, give me 1 second. I have to open up my computer and allow Zoom to, okay, there we go. I have to allow Zoom to let me share it. So let me do that. Okay, cool. Want that. Okay. That should be good. Larbel, can you do that outside, please? You need to go, honey. It's too loud. Yeah, it's too loud. Can you go outside, please? Okay. Here comes Papa. There we go. Can you guys see my screen? Yeah, okay, good. Thanks for the thumbs up. I see it. Okay, cool. All right, you guys, let's go ahead and begin. And as we're doing this, I think people will start to join in. I'm supposed to have like I might have like a waiting room, but I'm not sure. I don't see it. Okay. All right, so then for today's agenda, we are going to continue to follow the stamp sheet. So I'm just reminding you to make sure that you are following the dates and making sure that you're looking over the classwork. And I posted the solutions to that on Google Classroom, so you just need to scroll down. And then also making sure that you're actually completing the assignments from the stamp sheet. Those problems are really important that you get exposed to and that you practice so that you can master them next school year. And don't worry about mastering now, just get as much exposure as possible. Check-in for week number 4 is due tomorrow, and you can do it up to 3 times, but I'll tell you now, looking at those of you that have done it, it's been like 10 people, and I have 120 students. So there's a lot of you that have not done check-in week number 4. So after this Zoom call, that is the first thing that you need to get out the way so that you don't have to worry about it. And those problems are never the problems that I'm asking you to see if you understand or not. They're never problems from that week's lesson. They're always from the previous week's lesson. So the problems in there to check in for you are from the week before spring break. So this just review problems, nothing brand new, okay? So please make sure you get check-in week number 4 done as soon as possible. It's on Google Classroom. And then Khan Academy and sample MCIs are there for you for additional practice. Some of you are on Khan Academy in part of my class, but you haven't done anything from there. I had a student ask, does she have to watch the videos and do the practice? And you don't. The videos are only there to support you. If you don't understand how to do the practice problems, then you should watch the videos. But if you know how to do the practice problems, then the videos are unnecessary for you. So they're just there to support you. So just doing the practice on Khan Academy a few times would be very helpful for every one of you. And then also there's still the sample MCIs on our Math 8 website that you can do, and then email me for the keys. And that's really good practice for you. I would love to do some Zoom math team meetings. Some students have said that they're willing to host some meetings. Can you guys do me a favor? On your screens, I see like Evan is cool is raising his hand right now, but can everyone that is interested in doing a Zoom math team meeting, can you raise your hand on the Zoom? Not physically, but like in the Zoom. So I see one hand. Cool. Okay. Cool. I see 3 hands. Any other hands for those interested in doing Zoom? It's like there'll be like study groups, math study groups, and you can help you do some lessons together. Okay. Oh, good. Good. And you get to sign up on who you want to work with. I'll put up a sheet and you can sign up for it, and it can get you some extra credit points for the class. And you guys would just be doing some math Zoom meetings. Okay, cool. Good. Thank you for those of you that raised your hand. You can lower them now. What I've noticed is that there is a demand. There are people that want to do it. So I'm going to put some information out starting next week on Monday. And it's a way for you to sign up and then organize time that you would do your Zoom calls. I just ask that you don't do them while I'm teaching on Tuesdays and Thursdays at 9:30, but they would be on Monday, Wednesdays, and Fridays. And then you guys would choose the time that you would work after you figure out your math team. Evan, C, is there a question at all? Okay, Sally, you have a question? Oh, can you guys see this participant screen on my screen?
No.
No, okay, cool. Okay, good. All right.
My question was, for like the people in the team, should it be like people, like, can it be from any of your classes? Or?
Yes,
Okay.
it can be from any classes, yeah, which is so cool because you guys are already doing the same problems. And, you know, I think a team of like 4 or 5 students would be really cool. So you guys just work together, you talk about it, you get some support, have some fun, and then you can participate as much as you need to.
Okay.
Okay, thanks, Sally. Ruby, you have a question?
Yeah, I can't find the weekly check-in for some reason.
Okay, if you go to Google Classroom and go to the classwork tab, it's there as an assignment.
Yeah, I've gone there, but I can only find weeks 1, 2, and 3.
Shut up, you guys. Oh my, that's why students haven't been doing it? Oh, I did not know that was happening. Okay, can you guys see my screen right now?
Yeah.
Okay, cool. Okay, well, we're gonna do this real quick. We have time today anyways, because today's lesson is a 2-day lesson, but it's only a 2-day lesson because it's a lot of like construction, and we're not doing all that construction, so we have time. All right, let me go to the Math 8 classwork. Do they have theirs? Oh my gosh, how did I miss that? Okay. I'm so sorry, you guys. That totally makes sense why people haven't done it. So let me create. We use a post. Okay. Oh, it's there. Oh my gosh, I saved it as a draft. So it was here this whole time. How do I get the drafts? Why is it not here as a draft? Okay. Okay, that's fine. We can just reuse it from the draft. Okay. Sorry about that, you guys. All right, cool. Okay, yeah, it's all there. Is this weekend number 4? Okay. So I still had students get to it. I think if it's not on Google Classroom, always check your email because I'm pretty sure on the email I sent on Monday, I attached it there. So that's just for future reference, okay? And then let me go ahead and assign it. Okay. And then let me do math challenge while I have you guys here real quick so that that's done. Classwork. And there's the draft. Edit assignment. Okay. That's what happened. I had it in Math 8 challenge. Oops. Okay. So not Math 8 now. And assign. Okay. Ruby, thank you for calling that out. And then I don't know if you guys noticed from Zoom on Tuesday, I also posted chapter 2 slides, which was weird. I don't know how that happened, but I reposted chapter 9 for you guys. Assign. Okay, yes, I want them to see it. Okay, there you guys go. Okay, thanks, Ruby. And Tara, did you have a question? Or was it on
Yeah.
the? Okay.
I just wanted to say, so before I got on this Zoom,
Yeah,
I was so I got an email from you about like going to the Zoom and stuff.
yeah.
So then I used the password and stuff, but it wasn't I got on the Zoom, but it was not for math challenges. It was for math enrichment.
Okay, okay.
So
That
it was,
means,
yeah, it was a whole different password. And
okay. So I must have posted, how did I, okay, I have to look back and see how that happened. I'm sorry about that, but thank you for letting me know. That's
Yeah.
good. Okay, cool. And then Evan is cool?
Yeah. So you said that each Zoom that you attend can be one stamp sheet stamp?
I did not say that. I just said that that should be your math practice for the week. I mean, for the day.
Gotcha.
Yeah, for the
Gotcha,
day.
okay.
Yeah. So you should still try to do the practice. I mean, you guys have a lot of flexibility here. And if, let's say you did the Zoom lesson with me, right?
Yeah.
But then you still need to do the practice. And then you look at the practice the next day, but you realize I went through some problems that you already know how to do. You can skip those problems. You don't have to do problems that you know 100% how to do. It's really about just getting access and getting exposed to these problems and practicing as much as you can. Does that make sense?
Yeah.
Okay, cool.
Okay.
Okay, thanks for clarifying. Okay, you guys, yeah, I'm gonna, on Monday, I was gonna send out an email, just letting you guys know that the more feedback you can get me, the better I can be. So I really appreciate constructive criticism and feedback. And if there are things that are not correct, let me know and I'll correct it and fix it, okay? Just a lot going on right now. Okay, so then tomorrow, I've already done this, so it should happen. I'm gonna post April MCI tomorrow, and then I'm gonna post the key on the day of the fix it, which is not for like a couple of weeks. So April MCI, great opportunity to do this on a math team meeting. I'm okay with you guys working on the MCI together as long as you're understanding the material and asking questions. You're not just copying down answers. And you're welcome to work on it at your own pace at home. Maybe do one problem per day if you want, like you have time to get this April MCI done. Then I'll post the key in a few days. And then if you feel like, you know what, I really want to challenge myself, can I see the fix it? Then I will hand out the fix it to those that request it, but I won't post it on Google Classroom. Okay. And then today I have a few things I want to review. 9.2.1. which is from yesterday's lesson and today's lesson. And then I also want to review the last problem from the Zoom session on Tuesday. We'll do that first. And then I also want to review one problem from the weekly check-in that almost all students got wrong. So I feel like we should review it. All right, here we go. And do you guys notice like everything's working on my computer? Isn't that great? Yeah, I updated it. It took me hours, but I figured it out. Okay, so if your computer is not working and if you're having difficulty, update your stuff. I'm pretty sure that might be the issue. Okay, here we go. So this problem is from section 9. Here we go. Let me write it on there. Okay, this one is from section 9.1.4. Okay, so this is from Tuesday's lesson. And we were doing this in the Zoom and we were talking about similar triangles and how to tell if they're similar. And we ran out of time. So I wanted to go over it today. So I'll give you just a second to write down this example on your paper. Oops. There we go. Do you guys, okay, good. You guys are seeing the slide right now? Okay. All right, go and write down that example on your paper. We're gonna go over this problem. I forget which number it is, but it's part C. If you look in your textbook, you'll see it. And this problem is very similar to what we've done in the past on a mastery check-in, but it's bringing it back because now you understand angle similarity. remember, for two triangles to be similar, they have to have two angles that are congruent or are the same. And in this shape here, we have two triangles that are similar to each other, and we can tell because they have two angles that match up. And I'll show you how to do that right now, okay? I still see some people writing it down, so. While you're writing down, I just want to remind you, go to Google Classroom now, go to the classwork tab, and you'll find the weekly check-in form. And then also make sure that you check your emails, because I always put it in there as well, okay? I'm trying not to email you guys too much, but I'll send you emails at the beginning of the week with everything you need for the week. Okay, I'm gonna go ahead and start going over this problem then. So there is parallel lines here. This line ED is parallel to line BC. So you can go ahead and put parallel marks here. Okay. Then now that I have my parallel lines, I can see that it's being cut by transversals. Here is one transversal. So this transversal is cutting those parallel lines there. And if you can see, this angle here corresponds to this angle right here. And those are called corresponding angles when you're looking at parallel lines cut by a transversal. And so these, you can see that these two angles are going to be congruent to each other, okay, because they're corresponding angles. There's another pair of corresponding angles here. It's on the other side. This side has another transversal that we can draw. And so we have corresponding angles here and here. Notice the blue angles are the same, the green angles are the same. Oops, I should put 2 marks to show that the green angles are the same. Okay, so the green angles are the same, the blue angles are the same. That means that there's 2 angles for each of these triangles that are the same. Therefore, they are similar by the similarity postulate that we looked at on Tuesday. So that means the smaller triangle, let me erase this stuff now. That means the smaller triangle here is similar to the larger triangle by angle similarity. And you can write that out with the triangle. You see triangle AED is similar to triangle ABC. And now that we know that these 2 triangles are similar, we can actually break them apart. We can actually break them apart. So I'm going to do that now. I'm going to draw the larger one and the smaller one. So the larger triangle is going to be the ABC, and we have the side lengths of 15 and the side length x plus 8 for AC. This is ABC. And then if you notice, CPM already took out the smaller triangle, which is right here. So the smaller triangle has side lengths 3 and x. We've learned since last year, since 7th grade math, that you can set up a proportion to solve for the missing side lengths, which is here. So let me explain what this proportion is. It's saying that side length 3 is going to be similar to 3 plus 5 or just 15. So that's where I got the 15 from. This is 3 plus 5. So 3 corresponds to 15. And then you have x here corresponds to x plus 8. So you have x here corresponds to x plus 8. Notice they also have an equal sign in the middle. So this is a proportion when you have 2 shapes that are similar to each other. So we first proved that they were similar, and then now we're going to solve for the side lengths using a proportion. I want to remind you that to solve a proportion, you can cross multiply as a shortcut. So let me rewrite it here. It's 3 over 15 equals x over x plus 8. So now we're going to cross multiply. That means I'm going to do 3 times x plus 8. And then I'm going to set that equal to 15 times x. Some people call this the butterfly wings or the helicopter blades. It's just another way to solve a proportion. To continue to solve this proportion, we need to distribute 3. So we get 3x plus 24 is equal to 15x. At this point, you should balance 3x off of both sides. So I'm going to continue that here. Take away 3x from both sides. So you get 24 equals 12x. And then divide both sides by 12. So x is going to equal to 2. Okay. Please ask me questions. I'm going to pause now. Any question? Any question that you think somebody else might have? Okay, good. I see some hands up. Let me hear from Wendy first. Hey, Wendy.
Hi.
Hi.
So wait, how did you get 15?
Good question. Remember, 15 is the sum. Let me use red because I use red for 15. Remember, 15 is the sum of the longest side of the side of the bigger triangle. So 3, this is 5 here, or 3 here, and then 5. So 3 plus, oh wait, that's not 15. That should be
8. Yeah.
Oh my gosh, you guys.
8. Yeah.
Ay, ay, ay. Did I really confuse you?
Kind of.
Yeah, I'm sorry about that. I don't know why my brain thought 15. Okay, let me go ahead and clear it then.
So you add this 2 sides together.
Yes, you do.
Okay.
You do not multiply them. Oh my.
I was like, you
And you guys probably had your hands up for a while, right? You're like, Mrs. Fisher, stop. Don't do that. Okay, I'm so sorry. Well, you know what? I'm not sorry. I'm glad I did that because I made a common mistake that many students make. And I get to now correct that error and show you the process again. Okay? So let's please do this the correct way. 5 plus 3 is not 15. It is 8. Yeah. There we go. 8. Just kidding. Okay, sorry. It's still the eraser on. So it should be 8. So 3 plus 5 would give you the 8 over here. Okay. So now I'm going to do my cross multiplying. I'm going to get 3 times x plus 8 is equal to x times 3 plus 5, which is 8. So I get 8x. Then I do the distributive property here. And I get 3x plus 24. Oops. Oh my goodness. Equals 8x. Then I'm going to take away 3x from both sides. Am I doing this correctly? Is there a mistake here at all yet? Okay, good. No one said anything.
Wait, yes. No.
There is?
No, I don't know. Is there?
I don't know.
Oh,
I'm
wait.
asking.
Oh, never mind. Never mind.
Okay, good. Now I'm just making sure. Good. It's a group effort, you guys. Okay, so then we're going to take away 3x from both sides. I can actually show that here on this one. So we get 24 is equal to 5x. And then I'm going to divide both sides by 5. So I'll write that here. So now I'll divide by 5, divide by 5. So I'm going to get 24 over 5. So it doesn't simplify easily. And that's still the fraction answer, just as an improper or greater than 1, or an improper. And then this is going to equal x. And that would be my value for x, which is not so easy to find by just finding the scale factor. Building the proportion is super helpful in circumstances like this, because for this side AC, you have x plus 8. You know, and that's really challenging to be able to use a scale factor to find it out. But building this proportion is what's really helpful in solving for the missing side lengths. Okay, let me see if I got some other hands. Navaneet, do you have a question?
No, like, no.
Okay, was it the 3 and 5 where I made that?
Yeah.
Yeah. Okay.
Yeah.
My bad, dude.
It's fine.
Okay, good.
Mistakes happen.
They do, and we learn from them. So thank you so much. Okay, Finn, do you have a question?
Yes, I am just overall confused. I got here like 2 minutes ago because I clicked the wrong link, and now I'm overall confused about what's going on.
Okay, I apologize for the wrong link. That won't happen again. I'll make sure to double check. I was trying to do everything on Sunday, so I had everything ready to go, and it just kind of messed up. But anyways, let me go through this example one more time for you then, okay?
All right.
Okay, so we have 2 triangles that are similar, and we proved that they're similar because, oops, let me take that off. Oh, I did not want to do that. Okay, that's fine. We had two sides that were similar. Hold on one second. Abdullah, stop writing problem on my screen. You did that last time, dude. Okay. Sorry, you guys. It won't let me. Oh, there we go. Okay, cool. So we noticed that the bigger triangle is going to be similar to the smaller triangle. And we used angle pairs to prove that. That means we used parallel lines cut by transversal to prove that these two angles are congruent. Triangles are congruent. What we really figured out was that this angle here is corresponding to this angle, so those are congruent. And then this angle over here is corresponding to this angle down here, so they're congruent. And remember what we talked about on Tuesday is that two angles and one triangle are similar to another two angles and another triangle, or sorry, not similar, congruent to another two angles and a triangle, then they're similar. So we know that these two triangles are similar, so we can now apply this rule here. So what we did was we took the larger triangle, which is A, B, C, and we wrote down the side lengths. AC is x plus 8. All I did was add x here plus the side length 8 so I can get the total. And then on the other side length, AB, we got 3 plus 5, which is 8. And so now we're going to compare, they already gave you the proportion here to compare the different side lengths to each other. So we have 3 is corresponding, side length 3 is corresponding to AB, which is 8. So we do 3 all over 8, and they wrote 3 plus 5 to show you where the 8 comes from. And then side length AD, which is x, is corresponding to AC, which is x plus 8. So that's how they got x over x plus 8.
Okay.
Okay. And then they solved that proportion by cross multiplying. So then 3 times x plus 8 is equal to 8 times x. And we solved that for x. Okay.
All right. Thank you.
Yeah, you're welcome. That was fun, you guys. That was a ride. All right, let's move on. I'm gonna go to the next one. Thanks for asking the question, Finn. All right, this was the problem from the weekly check-in that most of you have not even seen yet, but I kind of want to review it just because those of you that have already submitted in work had incorrect answers. Like almost everyone that's done it had it incorrect. So I wanted to go over it just to make sure that we understand how to do it. So for this example here, P is parallel to Q in the figure. And they tell you that, but we can draw the arrowheads to prove that to show that they're parallel. And it wants to know what is the sum of angles 1 and 2, and that part that says sum can be confusing, right? So that means they want you to find angle 1, find angle 2, and then add that together because they want the sum of both. So if I try to figure out, how do I figure out the measurement of angle 1 or 2? Can someone explain that to us, please? How do I figure out the side length for 1 and 2? Sophia?
Well, 130 degrees is on that line, so then either 130 degrees plus angle 1 would equal 180 degrees.
Oh, good.
Or you could do 130 degrees plus angle 2 and you would equal also 180 degrees.
Perfect. And thank you for explaining that to us. So Sophia was telling us, since they make straight angles, we'll take 180 degrees, take away 130, and then what you'll have left over is how many degrees are left for 1 or 2, depending on which straight angle you're using. Since I'm doing the green, I'll use the straight angle with 130 and the angle 2. So 180 minus 130 gives us 50. Make sure you check my math. And 50 is going to be the measurement for angle 2 here. So that's 50 degrees. And then by vertical angles, angle 1 also should be 50 degrees. And then if it is asking for you to give the sum, you want to add the 250 degrees. And so your solution is 100 degrees. Okay. So I think it's the last problem on the check-in, you now know the solution to it. So make sure you guys get that one correct, okay? And if you are struggling with it, ask me questions or ask each other questions would be super helpful. All right, great job, you guys. Let's now get into today's lesson, which was also yesterday's lesson too. Oops, there we go. Okay, let me erase my screen. All right, do not copy this down. That would be a complete waste of your time at this moment. So don't copy this down at all, okay? I did post this on Google Classroom from Monday's post. So if you want this PDF, it's what you should have filled out while you were doing the activity, and it's just really hard to do without support. So I just gave you the solution so you can look at it to see what you notice. So what I want to just explain this a little bit. I'll go over the first part of it so you know what you're looking at. You have, what we're doing, you guys, is I would have gave you a bunch of different rectangles that were, a bunch of different squares. So I would have gave you 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, and they would have actually been like an actual square, okay? Like literally this, like a square that you would use, and then you would use the side length of the square to figure out which squares make a triangle and which type of triangles do they make, okay? So if we had a small square and we had the side length that was 3, that means that the square area would be 9, because 3 squared is 9. So if the side length is 3, then the area of that square is 9. I'll draw a picture on the side just so you know what I'm talking about. If I have a square and the side length is 3, 3 times 3 would give you the area of 9. That's where I got those numbers from. Then if I had a square with a side length of 4, then the area would give me 16. Area would give me 16. If I had, because in order for you to have a triangle, how many sides do you need? You need 3 sides, right? Good. I see people putting up 3. Good. So if I need 3 sides, that means for the third side, I'm going to have the largest length. The largest length for this triangle is going to be 5. And so the area is going to give us 25. Okay. So we found these 3 side lengths. We put these together, and then we found the areas of the squares. And so we took the small area and we're going to add it to the medium area. The small and the medium are going to give us 25. That means that the small and the medium are going to equal the large. And if your small plus the small area plus the medium area equals the large, you guys have a special right triangle. Let me say that one last time. You take the 3 different side lengths and you square those, right? So you get 9, 16, and 25. You add the small area and the medium area. If that equals the large area, you have a right triangle. That means I don't have to make it. I don't have to construct it. I don't have to know anything except for the side lengths to figure that out. That's huge. Right triangles is what almost everyone uses it constantly, and we don't even know that we use it so much. Okay, but what happens when it's not right? What happens when it's not a right triangle? Let me give you that example, okay? Let's go to a not right triangle. Here is an acute triangle. That means the angle measurements are going to be less than 90 degrees, which you can't see that. Let me do this. It's going to be less than 90 degrees. One angle would be at least not less than 90 degrees for an acute angle triangle. How do you know if it's acute? You take your 3 side lengths, 6, 12, and 13. You're going to find the area. So 6 squared is 36. 12 squared is 144. And 13 squared is 169. You're going to add the small and the medium, which is going to give us 180. And then 180 is actually greater than 169, which is the area of the large side. Since it's greater, then since the sum of the small and medium are greater than the large, we have an acute triangle. Okay. Let me go through the last one before I get questions, okay? Here goes the last one. The last one would be obtuse. How do we figure out if you have an obtuse? which is here, the sum of the smaller areas has to be less than the sum of the large area. What's weird is obtuse is really large, right? It's greater than 90 degrees, but the sum of the small and medium have to be less than the large. Acute is less than 90 degrees, but the sum of the small and medium have to be greater than the large. And if you want something to be a right triangle, it has to equal. All right, let me see if I got any questions here. Let me put this away. Can I get a question up in here? Does anyone have a question before I go over some example problems? Let me hear from Wendy. You have a question? Yeah, let me hear it.
Yes, I do. So in order for it to be like, let's say it was like, wait, did we do an obtuse triangle yet? No.
Yeah, it's down at the bottom.
Oh, so okay.
Yeah.
So if it's like smaller than 180, then it would, like, the triangle would be smaller. It can't.
So remember, 180 is talking about degrees, which is the inside of the triangle. We're trying to classify the inside, but we're using the side lengths to do that. So it's actually the sum of the it's the sum of the area of the side lengths. So we take, like, for example, 3 would be the side length, and you would square that, which would give you the area of the square, and that would give you the 9. So you want to take the side length squared to do it.
Kind of get it.
Okay, yeah, I think when I go over some example problems, so I just explained this chart so that you can look at it later yourself and kind of make sense of it, because if you look at it all at once, it's kind of confusing. But I'm going to go over I'm going to go over a bunch of examples for you right now. And I think that would be super helpful.
Okay.
Yeah, yeah. So let's wait till then, okay? And then Antara, let me see if you have a question real quick.
Yeah. Isn't this kind of like the theorem?
It is.
The theorem, the I don't know, the one that starts with the P.
Yes, Pythagoras theorem, the Pythagorean theorem, or Pythagoras, who's the name of the person that did it. And on Tuesday, when you actually look more into Pythagorean theorem, I'll post a video that explains the history. It's not long, but explains the history and explains how to do it. But yes, this is an introduction into that theorem. Yeah, you got it. So if you want to go ahead and look ahead and you have the time, since you're home, then you can look up Pythagorean theorem and see what it's about and where we're going, where we're headed. All right, let me go ahead and now do some example problems, because I think it would help make sense of what I'm expecting you to be able to do from this table, okay? So here we go, and we got time, which is good. Okay, here goes the example problems. I'm not sure who had written on the screen with the red right here, but if you can erase that, that'd be great. And the black there would be great too. Okay, it's just kind of blocking us. All right, go ahead and write down the first example that we're going to look at, which is side lengths 5, 6, and 7. So go ahead and write down side lengths 5, 6, and 7. This is problem 954. So we're going to do this together right now. And I'm actually going to share a whiteboard so I can go ahead and write notes on how to do this. Okay, so let me stop my share with this. Okay, so remember 5, 6, 7 are it. Let me share this screen, and I want a whiteboard. Okay, there we go. Great. Oh, that's how it does it. That's cool. All right, so the side lengths were 5. Oops, there we go. Okay. This is an example problem, but from problem 954, we're going to do A, and the side lengths of the triangle were 5, 6, and 7. Okay. So what does this mean? This means that we have side length 5, side length 6, and side length 7. And the first thing that you need to do, so I'm going to go ahead and give you guys some steps. The first thing that you have to do is figure out, does it even make a triangle? That means, you guys, I can give you different side lengths and it not even make a triangle. And if it doesn't make a triangle, then you can't figure it out if it's acute or obtuse or right, because it's not even a triangle to begin with. So the first step is it a triangle? And in order for you to do that, you just had to add the side lengths to figure it out. So let's see. In order for you to do this, if you haven't looked at this lesson, is you take the first two and you add them, and they have to be greater than the third side length. So 5 plus 6 has to be greater than 7 for it to be a triangle. Is 5 plus 6 greater than 7? Yes, good. I see some thumbs up. Thank you for those of you that are participating, and it's super helpful for me. Yeah, it is. And in order for it to be a triangle, you have to check all sides. So now that I did 5 and 6, I'm going to now do 5 and 7. Is 5 plus 7 greater than 6? Give me a thumbs up if it is. Give me a thumbs down if it's not. Okay, good. And then is 6 plus 7 greater than 5? Jayla, why is your foot up there? Thumbs up, not your foot. I see you on your phone. Okay, good. All right. Since these are all true and the two side lengths are greater than the third side length, then this is a triangle. So this is a triangle. So that is your first step, determining if it's a triangle or not. And we can tell that it is because two side lengths are always going to be, when you add them together, always greater than the other side length. Okay. Any questions on how to determine if it is a triangle? Just if it is a triangle.
Wait, did you say that? If it was?
Yeah, I said it is, but I want to make sure people know how to determine if it is. It's good. Zora, do you have a question?
7.
Yeah. How do you know, like, do you have to like add all of them before you figure it out, like every time, or?
Yeah, and I mean, you don't have to always write the work. It becomes a little bit easier just to look and tell which ones that you add together will give you, is it greater than the third one? But this does have to be the first step. You do have to check to make sure that all side lengths, if you add them together, will be greater than the third side length to create a triangle. Okay, does that make sense?
Yeah, that makes sense.
Okay, cool. Okay, good. Okay, great. Then, now that I've figured out that okay. Eli, you have a question before I move on?
Yeah, would there be a case in which the two smaller side lengths, like you added the largest side length and the smallest side length to see if it was greater than the medium side length?
Yeah.
Would there ever be a case where that wouldn't happen?
Yeah, there are. Yeah, there are cases where when you add two side lengths together, it's not going to be greater than the third one.
But at the same time, it's like still the larger is still, I mean, the two side lengths are still larger than the large side length?
If the two,
the medium one.
Yeah. If the medium one is, what do you mean?
If the two side lengths added together is still larger than the medium one.
Oh,
but
okay.
If you add the other two side lengths, it would still be larger, or never mind.
No, I think I kind of understand where you're coming from. You're just talking like in terms of if you check the medium side first or something, then yeah, you would know before having to check the other ones. That is true. Yeah, like that would make sense. But the checking, you don't actually have to write down. You can really, since you just add in the side lengths, check all the side lengths just to make sure. Like I would say just to do that, just to make sure.
Okay.
Yeah. But you're making sense of the whole situation. I'm pretty sure you're correct on what you're talking about. It's kind of hard to explain for both of us. Jeremy, you have a question?
So basically, like this with the side lanes, like 3, 3, and 6, it would not be a triangle.
Exactly. Yeah, exactly. Because 3 plus 3 is 6. So if you did, so really quick, you guys, if you had 3, 3, and 6, right? 3 plus 3 is 6. So this would not create a triangle. It would actually just be a straight line, right? Because the side length of 3 would come down here, and there would be 3 length here. And then this side length of 3 would come down here, and this would be 3 here. So it would just be a straight line. Good brought up. Another one that is also like not a triangle, if I had 4 4, 6, and 10, right? 4 plus 6 is 10. So that means that you would just get a straight line. There wouldn't be a triangle here. So it always has to be 2 side lengths added are greater than the third side length for it to be a triangle. Wendy, you have another question? Thanks, Jeremy, for that addition.
So let's say that it was like 1, 2, and 3 or whatever.
Yeah.
Like, what happens if they're equal to each other? Is it like not a triangle or like?
Yeah. That's examples I just went through. It gives you a straight line, right? 1 plus 2 gives you 3. So they would just fold down and you would just have a straight line. It wouldn't create a triangle.
I got it.
Yeah. Good.
Okay.
And good. Thank you. For those of you that might also still be struggling, even though all these people asked all these great questions and gave all these observations, I put videos yesterday on Google Classroom that go over this concept. So you can watch it again and again. There's a guy that does exactly what I'm doing now, so you can see it again and again. And I think I might be recording this session, so I might be able to post it, but I'm not sure. I don't see it saying recorded, but I'll have to see. So if anything,
recording for me.
it does? Oh, okay, good. Perfect. Yeah. So then this is recording. I'll post this today on Google Classroom. And then you also have the videos that I posted yesterday that can help you. Okay, you guys, we've only done step 1. So step 1 is figuring out if it is a triangle. And we would have spent all day yesterday on Wednesday figuring this part out. And then today would have been the part where we figure out, okay, if it is a triangle, then what type is it? Is it acute? Is it obtuse? Or is it right? And that's when you need to do the area. And that's when you need to square the side length. So be careful. A lot of kids confuse step 1 with step 2. Try to keep them separate. That's why I'm writing down all this work, okay? So step 1, is it a triangle? We just completed that. Let's now do step 2, which I'm going to do in red. Okay, and I'll do it right over here so I don't have to lose my screen. Okay, so here goes step 2. Step 2, then you need to take each of the side lengths and you need to square them. So you're going to take 5 and you do 5 squared and that gives you 25. You're going to take the side length 6 and square that. So 6 squared is going to give you 36. And then you're going to take 7 and square that and you're going to get 49. And now the question is, if I take the small side, which is the 5 squared, 5 side, and I square that answer, then I take the medium side, which was 6, I square that and take that answer. If I do 25 plus 36, how does that compare to 49? How does that compare? Now, if the sum of the 2 smaller sides is greater than the larger side, then I'm going to get, greater is going to give me acute triangle. So 25 plus 36 is greater than 49, I get acute. If 25 plus 36 is equal to 49, I'm going to get a right triangle, which are special and very helpful and super, 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 super useful. You use it a lot in math. And then if I get 25 plus 36 is less than 49, I'm going to get an obtuse triangle. So hopefully you wrote down everything on my screen because this is like a summary of notes from yesterday and today. All right. Can I have someone volunteer? What type of triangle do we have then? What's 25 plus 36? Is that greater than 49, equal to 49, or less than 49? Zora, let me hear from you, please.
It's an acute triangle because it's greater.
Oh, good. Okay, so does everyone agree with that? Well, sorry, I need to see you guys' pictures. Let me see. Okay, nod your heads if you agree. Okay, cool. Give me a thumbs up on your screen. Awesome. So then Zora was correct. She took 25 and 36, and when she added that, that was greater than 49. Therefore, it's an acute triangle. Okay. I feel like that went really well, but I want to see if there are questions first. Finn, do you have a question, please?
Yeah. So for step 2, does it always go in a particular order? Like you have to add the other 2 to get to the longest length?
Yeah.
Or?
Yeah.
Yeah.
You should always go in this order. Yeah. So like, let's say they gave you 7 first, then 6, then 5, you need to know that the side length we're talking about is going to be that you still need to do the longest side length that you compare it to. Yeah. So it's always small, medium, then large. So you always have to put it in that order.
All
Good.
right.
Good. Okay. Other questions? Okay. Cool. Okay, let's do another example then before we get start to like wrap up. Let me, how do I do this? Oh yeah, okay, cool. I just need to look at my screen. Oh no. Okay. Let me take this off for you guys so we can look back at the presentation. Okay. Okay. Oh, not there. Oh, what happened to my screen? Oh, there it goes. Okay, cool. Here goes the next example. Let's do desktop so you guys can see it. Okay, here you go. So let's do part B. We have 2, 11, and 15. 2, 11, and 15. And before I even whip out the whiteboard, I first want to ask, is B a triangle? Yes or no? And if you say yes or no, can you tell us why? Let me see who raises their hand first. Ooh, Sally, let me hear from you, Sally.
I don't think B would be a triangle because, like, just to look at it, like 2 plus 11 would not equal 15. And so then you know that it wouldn't, like, add up like before when it was like 5, 6, and 7. It doesn't add up to be larger.
Good, perfect. Okay, so you first said equal, but then you fixed it and you said larger. Beautiful response. Yeah, 2 plus 11 is 13. That is not greater than 15. So automatically, B is not a triangle. So let me go ahead and cross it off or put not a triangle. So then you can't determine if it's acute, obtuse, or right because it's not even a triangle to begin with. So you should just leave that alone, okay? Avery, do you have a question? Oh, no, okay, cool. Okay, then let's then look at part C. Is part C a triangle? And if it is a triangle, how do you know? Finn, is part C a triangle? And how do you know?
Yes, because they would all add up to more than each other.
Okay, well, they would all be greater than the third side, right? Okay, good. Oh, let me see. Okay, good, yeah. So they're going to be greater when we add up the side lengths. They're going to be greater than the third side length. So here, 10 plus 15 is going to be greater than 20. 15 plus 20 is going to be greater than 10. And 15 and 20, if we add those up, they'd be greater than, oh, I already said that, right? They'll be greater than 10. Yeah, good. Which one am I missing? 10 and 15 greater than 20. 10 and 20 greater than 15. And then 15 and 20 are greater than 10. Good. So this is a triangle. Now that we know 10, 15, 20 is a triangle, let's see what type of triangle it is. So I'm going to stop sharing this screen. And then I'll put the whiteboard up, okay? Okay, so what were the side lengths again? There was 10, 15, and 10, 15, 20, right? Okay, let's go ahead and write down that example then. So we have side lengths 10, 20, and 15. Notice I didn't put my largest side length last, but I'm going to do it last. So please make sure that you always do the largest side length last, okay? This is where it's really handy to know your perfect squares. And I know all the way up to 15, so I encourage you to memorize your perfect squares up to 15. I'm going to first do 10, which is the smallest side length, and I'm going to square that, and I get 100. Then I'm going to take 20. Oops, sorry, I don't want to take 20 because that's actually my largest length. I want my medium length. So my medium length is 15. So 15 squared is 225. And then I'm going to do my largest side length, which is 20. And so then 20 squared is going to give us 400. And now what we have to do is we have to take the two smaller side lengths, which is the 10 and 15, and we have to take their areas or their squares, which are 120, 225, so 100 plus 225. And the question is, how does that compare to 400? Remember, if it's going to be greater than, it's going to be acute. If it's going to be equal to, it's going to be a right triangle. And if it's going to be less than, it's going to be obtuse. So can someone tell us which one this is? Someone I haven't heard from. So let me hear from Eli. You haven't answered the question yet. Go ahead, Eli.
It's obtuse.
Okay, how do you know that?
Because the largest side length is larger than the other two combined.
Awesome, good. So if we take 100 and add 225, that's going to give us 325, which is going to be less than 400. And if that happens, that gives us an obtuse triangle. All right, you guys, we have 3 minutes left. So I wanted to give some time to just to chat and be all unmuted. But I first want to see if there's a last question before I take this off the screen. Okay. Okay, cool. Good. Well, great news. I fixed my laptop. Isn't that awesome? I didn't drop the call. I can write on the screen. You can see the slides. I've been doing all this work. I wish I would have figured this out 3 weeks ago. That would have been so nice. So I'm glad that I figured this out now. But it's really good to see you guys. I hope you're being safe and healthy out there. You guys are pretty much unmuted. Do you guys find the Zoom calls to be helpful? Yeah?
Yeah.
Okay, so I should continue doing them? Yeah. Okay, cool. All right, I'll post this video if it recorded. Oh, it's still recording. Cool. So I'll post this video. I'll post some math puzzles today. April MCI is going to come out tomorrow. Okay, what is this?
It's Endgame.
What movie is this?
Endgame.
Endgame?
Can you just leave the Zoom call going? Can you just leave the Zoom call going?
We should do like a watch party. That's what we should do for watch party.
No, I'm balling. Usual like Kobe.
Okay, I'm gonna leave the meeting, but I'll let the meeting keep going, okay? Oh, this is Avengers Endgame? I haven't seen this yet.
How about mail?
Oh, how do I watch this?
2 busters, please. Thanks, Mama.